Good morning, everyone. I welcome you all for the lecture on Mechatronics Sensors and Transducers, Unit 1, Session 7. In the previous session, we have discussed about velocity sensor, that is a tacho generator, which is used for measuring the rotational speed of a shaft. A force sensor, that is a load cell, which is used to measure the force acting on the member. A fluid pressure sensor, it is used to measure pressure in a system. We use various types of elastic membranes like diaphragm, bellows, capsule, or Bourdon tube. Fluid flow sensors. A turbine flow meter is used to measure the flow of a fluid in a pipeline. Liquid level sensor. Liquid level sensor uses a simple float, lever, and a potentiometer mechanism to detect the level of liquid in a vessel or a container. A piezoelectric sensor which converts the deformation of a material into equivalent voltage either to measure the force or deflection. In the current session, we are going to discuss about what is temperature, what is the what are all the various categories of temperature measuring sensors, construction, working, and applications of bimetallic strip, resistance temperature detectors, thermistors, thermodiodes and transistors, thermocouples, working of light sensors like photodiodes and photoresistors. Finally, discuss about the factors considered in the selection of a sensor. Coming to the temperature measurement, we use various types of temperature sensors, but we should know what is temperature. Temperature is degree of hotness or coldness of a body. Temperature measurement primarily uses the expansion or contraction of solids, liquids, or gases, as in mercury bulb thermometer. But nowadays we use change in electrical resistance of conductors and semiconductors to determine the temperature of a body. By measuring the thermoelectric EMF also, we can determine the temperature. The various types of temperature sensors are bimetallic strips, which uses two metals made up of different materials bonded together having different thermal coefficient of expansion, resistance temperature detectors. In these devices, resistance increases with increase in temperature. By measuring the change in resistance, temperature is determined. Thermistors. A thermistor is a semiconductor material having negative coefficient of thermal resistance. Thermodiodes and thermotransistors. These devices operates in the range of -80 to +150 degrees centigrade. The relationship between current and the voltage drop is proportional to the temperature of the body under consideration. Thermocouples. The thermocouples have hot junction and the cold junction. Hot junction is placed at the body where temperature is to be measured. Cold junction is maintained at a reference temperature. An EMF developed in the thermocouple is proportional to the temperature of the body. The first type of temperature sensor is a bimetallic strip. It uses two metal strips made up of different materials having different thermal coefficient of expansion are bonded together. It is called as a composite strip. When this strip is heated, it deforms. Strip having higher coefficient of thermal expansion expands more. Strip having lower coefficient of thermal expansion expands less. This movement of the strip is used to either to make a contact or break a contact. So bimetallic strip is used as a thermostat. There are two metal strips here. They are bonded together with a soft iron and a small magnet at one end to make or break the contact. When the temperature is increased, bimetallic strip deforms more, closes the circuit, and power flows to the system. When the temperature of the body is decreased, the strip straightens, opens the contact, so there is no power flow, or vice versa condition may also occur to either to make the circuit or break the circuit. Working of a bimetallic strip thermostat is understood by the help of this video. This is the iron box heating element. The power supplied to the iron box heating element is controlled by the help of a bimetallic strip here. The next type of temperature sensor is resistance temperature detector, abbreviated as RTD. Resistance temperature detectors uses simple resistive element. It uses change in resistance of the conductor to measure the temperature. The resistance of the conductor varies with temperature as shown here. As the temperature increases, resistance also increases. Thus, it gives a positive change in resistance with respect to the temperature. RTDs, they are made up of simple resistive elements. They are made up of simple resistive elements here. These simple resistive elements, they are in the form of a thin film, wire wound, or coils of metals made up of platinum, nickel, nickel copper alloys, but platinum is most widely used. Coming to the construction of resistance temperature detector, this resistance temperature detector has got a platinum coil. This platinum coil is placed in a tube made up of stainless steel or copper steel, and the two leads are taken out, and the whole arrangement is placed in a protective tube for providing the protection against the damage. The platinum wire is wound on a ceramic bobbin. In operation, when the tip of the RTD is heated, there is a change in temperature due to which the resistance changes. The final resistance is given by the equation RT is equal to R naught into 1 plus alpha T, where RT is the resistance at a temperature T degree centigrade, R naught is the resistance at 0 degree centigrade, and alpha is the temperature coefficient of resistance. As the RTD is heated, its resistance changes and proportionally the voltage increases. When no heat is supplied to the RTD sensor, the voltage decreases because of change in resistance. The various applications of resistance temperature detector includes the automotive industries, where it is used as engine oil temperature sensor, intake air temperature sensors. It is used in communication and instrumentation as a temperature sensor and amplifiers, transistor gain stabilizers. It is used in consumer electronics, that is in small appliance control and in fire detectors. It is used in industrial electronics as a gas flow indicators, and it is used in plastic laminating equipment. It is used in medical electronics, mainly in blood dialysis equipment, as well as in infant or children incubator. Thus, RTDs, they are used in automotive, medical, industrial electronics, consumer electronics, instrumentation, and the communication field. Thermistors. Thermistor is also a temperature sensor. In these devices, resistance changes rapidly with respect to temperature. Hence, these are highly sensitive devices. They are made from a mixture of metal oxides such as chromium, cobalt, iron, manganese, and nickel. These oxides are semiconductors. The material is formed in various shapes like beads, probe, rod, or disc. In thermistors, resistance decreases with increase in temperature. Such type of thermistors we call them as negative temperature coefficient thermistors. In certain type of thermistors, resistance increases with decrease in temperature. We call them as positive temperature coefficient thermistors. Thermistors respond very rapidly to a temperature change. This slide shows the thermistor and its circuit. Here, as the temperature falls down, resistance is increasing and LED is glowing, indicating that there is decrease in temperature. As the temperature increases, resistance is falling and LED is not glowing. It's a highly sensitive temperature sensor. So as the temperature is increased, the resistance drops very drastically as shown here in the graph. Coming to the application part of thermistors, thermistors are used in fire alarms, ovens, and to control the temperature in refrigerators. They are used to measure the temperature in digital thermometers. Today we are using digital thermometer instead of mercury thermometers. It is used in automotive applications to sense the temperature. The next type of temperature sensor is a thermodiode. Thermodiode is a specially designed semiconductor diode which is used for temperature sensing. They are more sensitive to temperature measurements than any other device. In principle of operation, as temperature is increased, the mobility of charge carrier increases. This increases the electron hole diffusion across the PN junction. If V is the potential difference across the PN junction, current I through the junction is a function of temperature. Thus, the temperature is measured in a thermodiode. Thermistors are even more sensitive than thermodiodes. The same or the identical situation occurs in measuring the temperature in a thermotransistor. But here, voltage across base emitter junction depends upon the temperature of the object. Two transistors with different collector current determine the difference in base emitter voltage. This difference is directly proportional to the temperature on the Kelvin scale. This sensor can be used in the range of -40 to 110 degrees centigrade, and it gives an output of 10 millivolt per degree centigrade. The next type of sensor is a thermocouple. Thermocouple is also used as a temperature sensor. Two different metals are joined together, and the potential difference across the junction is used to determine the temperature of an object in a thermocouple. These are the two metal wires made up of different metals. They are joined together at the ends. One end is placed near the object where temperature is to be measured, and the other end is open to the atmosphere, or it acts as a reference junction. The voltage across the two metal wires is measured, which is proportional to the temperature of the body at hot junction. So it can be understood very easily in this slide. Wires of two dissimilar metals are welded together at both the ends. It has one hot junction and it has got one cold junction. Hot junction is inserted where temperature is to be measured. Cold junction is maintained at a reference temperature or it is open to the atmosphere. With different temperature at both the ends, an EMF is developed. This EMF developed is proportional to the temperature at the hot junction. If both junctions are at the same temperature, there is no EMF. If there is a difference in temperature between the two junctions, an EMF is developed. The value of the EMF developed mainly depends upon the two different metals used and the temperature of both the junctions. Commonly used thermocouples are chromal aluminal, iron constantine, and chromal constantine, etc. Applications of thermocouple. Uses of thermocouple ranges from home applications to industrial processes. It is used in electric power generation, furnace monitoring and control, food and beverage processing, automotive sensors, aircraft engines, and finally, rocket to satellite and spacecraft applications. Light sensor is also a temperature sensing device. It is called as a passive device which converts incident light energy on the sensor into an electrical signal. Both visible and infrared part of the spectrum is converted into electrical energy in these types of sensors. Light sensors, they are also called as photoelectric devices or photosensors. They convert photons into electricity. It is a PN junction diode connected in reverse bias in a circuit to measure the parameter. With no incident light, no reverse current flows in these photodiodes, and it is termed as the dark current. So this is the circuit of a photodiode. When light falls on the junction, PN junction, there is an increase in the reverse current and the resistance and the diode resistance drops drastically. The reverse current developed is proportional to the intensity of light that is falling on the photodiode. As we see here, as the light intensity increases, the reverse current or the reverse current is also increasing. Photoresistors. Photoresistor, it is a combination of photon and resistor. A photoresistor is also called as an LDR, light decreasing resistance or light dependent resistor. It is also a passive device which decreases the resistance with respect to the intensity of light on the photoresistor surface. In a photoresistor, resistance decreases when light falls on it. It is nothing but conductance increases with increase in the intensity of light. This property we call it as photoconductivity of the material. These photoresistors are also known as photoconductive cells, or just we call them as photocells. The last part of this session is selection of sensors. That is, what are all the different factors considered in the selection of sensors? The first and the foremost factor we require is the accuracy of the measuring instrument. The different environmental conditions a sensor has to work, whether it has to work in a normal temperature environment, or in a cold temperature environment, or a high temperature environment, and the range of measurement required, how often it requires calibration, the resolution required, cost of the equipment is also an important criteria, repeatability of the instrument, nature of output required, whether we require an analog output or a digital output, quantity to be sensed, mechanical stability or the ruggedness of the instrument, electrical stability of the instrument. These are all the various factors we consider in selecting a particular sensor for particular application. So, in the session 7, we learned what is temperature, classification of temperature measuring sensors, construction, working, and applications of bimetallic strip, RTDs, thermistors, thermodiodes and transistors, thermocouples, working of photodiodes and photoresistors, and what are all the different factors which are being considered in the selection of a sensor. These are the references we have used. Coming to the multiple choice question. The first question is, what is the effect or properties of LDR when light falls on it? Its resistance remains the same, its resistance changes, its capacitance changes, its inductance changes. The answer is B. When light falls on an LDR, light dependent resistor, its resistance changes. It is inversely proportional to the intensity of light. Thermocouple generates output voltage according to circuit parameters, humidity, temperature, voltage. The answer is C. Thermocouple is a device which is capable of producing output voltage according to the input temperature. Output of a bimetallic element will be strain, pressure, displacement, voltage. The answer is C. Bimetallic element is used for measuring temperature. It produces an proportional output displacement for the input parameters. Question number 4. Which of the following is true for bimetallic type thermometer? Two metals have same temperature coefficients. Two metals have different temperature coefficient. One metal is cooled always. None of the above. The answer is B. In a bimetallic type thermometer, two metals are used which are having different temperature coefficient. Question number 5. When bimetallic thermometer is heated, curling occurs to the side of the metal with least temperature coefficient? True or false? It is true because a bimetallic thermometer, when heated, curls to the side of the metal with least temperature coefficient. Number of curls will be proportional to the temperature applied. Sixth question. Thermocouple is a primary device, secondary device, tertiary device, none of the above mentioned. The answer is A. Thermocouple is a device which converts thermal energy to electrical energy, and it can be treated as a primary device. Operation of a thermocouple is governed by Peltier effect, Seebeck effect, Thomson effect, all of the above mentioned. The answer is D. Operation of a thermocouple is based on three major effects. Pelton, Thomson, and Seebeck all describe the relationship between current flow and the temperature between two different metals. Question number 8. Dash describes current flow between two junctions formed by two different metals. Peltier effect, Thomson effect, Seebeck effect, none of the mentioned. The answer is A. When two different metals are connected to form two junctions, current flow will occur from one junction to other. This is described as the Peltier effect. Question number 9. Peltier effect is a reverse of Seebeck effect. True or false? The answer is A. Peltier effect and Seebeck effect operations are reverse to each other. Question number 10. Which of the following is correct for thermistors? Positive temperature coefficient of resistance, negative temperature coefficient of resistance, unpredictable temperature coefficient, none of the above mentioned. The answer is B. For thermistors, as temperature increases, the resistance decreases. So, in Unit 1, that is mechatronics, sensors and transducers. So we discussed about what are all the different areas of applications of mechatronics system, what are all the advantages of mechatronics system, then what is a measurement system, what are all the different types of control system, open loop control system and closed loop control system, different types of sensors and transducers classification, its performance terminologies, then the sensors used for displacement measurement, velocity measurement, force measurement, fluid pressure measurement, fluid flow measurement, measurement of fluid level, then different types of temperature sensors are discussed in Unit 1. And finally, what are all the different factors considered in the selection of a sensor are the things which are being discussed in this particular chapter, that is Unit 1. Okay, thank you.